So I want to finish off these slides today. We started looking at the Cognito service last week, so I just need to finish that topic. And there's a lab on Cognito as well. And in fact, the code that you will produce as the final result of this lab, you will be able to reuse that in the assignment. And at the end of this lecture, I'll give you an opportunity to ask me any questions that you might have on the assignment spec. Everybody has read over it now at this stage. So if there's any clarification that you need, you can put them to me uh, orally, really, rather than via chat. Okay, so that's the plan for today. So I started talking about Cognito last week with you. And we know essentially what it's about. It's about managing your user profiles, if you like, and giving users an identity so that they can access resources that you have in your account. Although really it's about accessing applications. It could be resources as well, like, access to an EC2 instance, access to an S3 bucket. We're not looking at it from that perspective, though. We're looking at it from the more, uh, I suppose we call it traditional user access requirements, as in user registration, user login, and then accessing actual applications. So what we said was that Cognito has two main kind of constructs, or two main types of resources, sorry, user pools and identity pools. And it's the user pools that we will focus on. Okay, and Cognito, and in the context of user pools, Cognito has all of these other kind of services that do, sorry, it has all of the main kind of aspects of user account management, as in user registration, user login, disabling users, password resets, and all that. I think that's roughly where we left things off the last day. So, in very kind of broad terms, this is what we're looking at, and Cognito kind of plays with API Gateway because we're still going to be using API Gateway as our entry point, or users are going to be using that, or clients, I suppose, really more generally, are going to be using an API Gateway as the entry point to your applications. But an API Gateway then will be talking to Cognito. Even though this image might indicate here that there is some sort of direct communication between Cognito and the client, that's not really the case. So this image is a very kind of high level overview of where Cognito fits in an overall applications architecture. Uh, what Cognito will be doing is it will generate JWT tokens. Presumably, I'm assuming people are familiar with JWT tokens from somewhere in your previous studies. So it generates these tokens, and these tokens then are what are used by a client to essentially authenticate itself with API Gateway for the purpose of accessing some back-end functionality, which in our case would be Lambdas, but it doesn't have to be Lambdas. Okay, so straight into code then from a CDK stack point of view, we want to be able to provision a user pool. And this code excerpt is showing you how to do that. So really, it's all starting to look fairly familiar now at this stage. We create a new instance of another L2 construct. And like all L2 construct, it has a scope, it has a construct ID, and it has the configuration. So the configure, and this is kind of the bare minimum configuration that you might want to set for a user pool. This one here is sort of indicating that we're allowing users to not just register, but to confirm their registration. And we'll see what we mean by that in a moment. We're going to allow emails to be used as kind of aliases for users' usernames. You can define many attributes that you want to associate with a user profile. Now, apart from the standard ones of username, password, email address would probably be a standard one as well, but you can have other attributes, and you can define custom attributes that you might want to associated with each user profile. We're all kind of familiar with when we register for certain services online. Some services require us to provide more information than others, like, what company are you working with, what's the size of the organization, all this kind of stuff. We could do that as well, but we don't really need those extra aspects. The removal policy is a bit like with DynamoDB. Do you want to delete this user pool when the stack, is deleted? And I'm just, because it's only in development mode, we're saying, yeah, whenever we delete the stack, delete the user pool as well. Probably would not be the case in a production environment. As well as creating a user pool, you have to create a client as well with that user pool. Okay, it's just got to do with the internal kind of mechanics of how all of this works. So just for now, just as far as we're concerned anyway, whenever you create a user pool, you can actually create more than one client, but you do need to create at least one client. Otherwise, you won't be able to interact with the user pool. As we'll see when we start looking at actual code, every time we want to do something to a user pool, like add a user, modify a user's profile, we have to not only specify the user pool that we're referring to, we also have to specify the client that we want to use to carry out that action. And the client's configuration, again, is it an L2 construct? It's not actually, it's just it's part of the configuration of our user pool. It looks like we have to specify the authentication flow. There can be more. There are a couple of, I think there's probably only one or two built-in authentication flows, but you can actually define your own authentication flow, which we won't be doing. We'll use these kind of standard authentication flow, as in registration, login, logout, registration confirmation. So that's pretty much kind of boilerplate stuff, really, that you would have in any CDK stack that requires a Cognito user pool configuration. Create a user pool, create a client for that user pool. And all I'm showing you down here then is a screenshot from the Cognito management web management console, which we'll see in a while anyway. This is a more detailed breakdown of what I showed you 2 slides back. Now, what we're saying here is, or what I'm showing you here is what is often used as the actual architecture. You don't have to follow this architecture. We will in the lab, and you will in the assignment as well. And so what I'm showing you here is that typically you actually might have one API, web API, that's dealing with all Cognito-related requests, like registration, login, logout, and a separate web API that's dealing with all requests targeting your actual application's functionality. It's just a better kind of breakdown of responsibilities, rather than having one API dealing with all types of requests, which is kind of, if I just go back for a second, that's kind of what we were suggesting here, just have one web API. but it's considered a better design maybe to break the overall role of this web API into two separate web APIs. And so, as I said, now when your client wants to log in, that request is going to be targeting this web API, and there's going to be a bunch of lambdas here, which they're fairly standard, but we still have to provide them. The lambdas will be taking care of whatever the nature of the user request is. Is it a user registration? Is it a user login? Is it a user password reset? All that kind of stuff. So this API gateway will route the relevant request, or will route the request to the relevant lambda. And the lambda then takes care of talking to Cognito. Uh, and so for your typical kind of, assuming the user has already registered now, when the user logs in, that request will be sent to this web API. It will forward the request on to the relevant lambda. The lambda will talk to Cognito, as in, verify that the username password combination that was provided are correct. Cognito then will return a JWT token if the login is correct, and that token then is sent back to your client, and the client uses that JWT token then for all subsequent communications with this web API as a means of authenticating themselves against this web API for the purpose of accessing backend functionality. This web API then it needs to integrate with a Lambda, and the purpose of this Lambda is to verify that the token, the JWT token, is a valid token. Now, I should really actually have a link here, right? Because this Lambda will actually get Cognito. It will work with Cognito for the overall purpose of verifying that the token is a valid token. And the way this Lambda will kind of communicate to the web API as to whether the token is valid or not is it will dynamically generate a simple IAM policy, and the policy will either allow or deny the original request to be forwarded on to the back end. Okay. Now I'm giving you the code for this, and again, you can treat it as boilerplate. You won't need to go making changes to this code. It works. Okay. You won't need to go making changes to it in relation to the assignment, right? But that is what it does, right? It talks to Cognito, and the overall purpose is to validate the JWT token. And if it is a valid token, this Lambda will dynamically generate an IAM policy, and the policy will either indicate a deny or an allow access to the backend. Yeah, that's how it will work. So we know how to create web APIs. We just need to really, I guess, look at some of the lambdas that are up here. And again, there's nothing terribly exciting about them. They're just talking to another service. Like we've already looked at lambdas that talk to the DynamoDB service, and we've seen the kind of programming model associated with that. Turns out that the programming model for talking to Cognito is very similar, and that's good because it's a kind of consistent programming model across all the different types of services that a Lambda might want to talk to, rather than having to learn a different programming model for each different type of service. There's a common kind of programming pattern used for every service that a Lambda might talk to. Okay, so here we're just looking at, on the left, we're looking at the detail of sorry, if I go back here, we'll refer to this as the Auth API and this as the App API, just for convenience, right? So the Auth API, these are the kind of endpoints it's going to have, And if you just scan down through them, they look like the type of endpoints that you would expect an authentication API to have. My app API is just trivial, right? All we really want to prove is that the validation of the token actually kind of works and that this does pass on a request. Let's say some of the lambdas here are publicly accessible, which means uh, they don't really need, the user doesn't really need to provide a valid token when they're trying to access them. Some of the other lambdas are protected, meaning that the user does have to provide a valid JWT token before they can actually trigger them. But I've just, for simplicity, we're just going to have two lambdas here, one which is publicly accessible, the other which is protected, which is why we've got two endpoints in our app API. Down here then is just a screenshot from some of the lambdas that make up our overall kind of stack. And you can see again that these lambdas kind of correspond to the backends for this auth API, whereas these two lambdas down here are the backend for this app API. And this is the authorizer lambda, this one here. So what's next? Okay, so if I just switch over to VS Code, here's my full CDK project. And, here's the various lambdas that I showed you on the screenshot. Yeah. Here's my stack file. Where's my stack file? Here's my stack file. Where is it? Here, yeah, sorry, yeah. So it's a class that extends stack. That's fine. So this is my stack file. Now I've thrown something else into the equation here just for demonstration purposes. Like up to now, we've had a stack file, and all of our infrastructure as code has gone into this stack file. But, from a design point of view, just a general kind of programming design point of view, it would be nice if we could take logical blocks of that code and put them into a separate class of their own. Yeah. Now, in CDK world, what that would mean is take a logical, and I emphasize some sort of logical block of code from your stack file, and we would put that into a custom construct, right? Up to now, we've been using L2 constructs that have come with the framework, with the CDK framework. But we can define our own custom L2 constructs. And so that's what I've done actually. I've defined two custom L2 constructs for myself, which you can see here, right? And they make kind of sense in that one of the constructs looks like from the name anyway, this construct is responsible for generating all of the infrastructure code related to the app API. And the other construct, uh, it has all of the infrastructure code related to the auth API. And if we just look at one of them in kind of high level terms, so, we're defining a class. That's the name of the class. But in this case, the class, it does not extend stack. It extends the construct superclass that comes with the framework. And I'm importing that from the actual framework itself. Right? So you can define your own L2 constructs, and I've done it here for demonstration purposes and also just makes the code a little bit easier uh, to follow, I think. So I'm going back to my stack file then. What I'm doing in the stack is I'm creating my user pool. We've seen that from the slides. I'm creating, uh, let's see now. I'm creating my user pool. Uh, okay, that's all right. That's okay. I'm just getting the user pool ID. That's all right. I'm creating my client for my user pool, which I talked about in the slides. And I'm extracting the client's user pool. Is it a client that user pool client? That's okay. I'll just and here then, here's where I'm using my own one of my custom constructs. I'm creating an instance of my auth API L2 construct, but of course that's now going to explode into creating the auth web API, instantiating the various lambdas, uh, connecting or integrating my lambdas with the auth API. We've seen all that kind of stuff when we were talking about web APIs. I'm creating an instance of my app API as well, my second L2 construct. And that's it. That's my stack. So my stack looks a lot kind of neater, I think, because we've actually defined our own custom constructs. Oh yeah, um, the thing is though that we do need to pass some uh, information down into these custom constructs of ours. And sorry, that's what I'm doing. That's what I'm doing here and here, right? I'm just defining two local variables essentially. One is going to contain the user pool ID. The other is going to contain the user pool client ID. And I'm passing those down into my custom constructs because they're both going to be using the user pool. Right. In terms of the signature of these custom constructs, it's the same as before, right? It's like every L2 construct. My custom construct has a scope property. It has an ID kind of string, and the configuration part then that is specific now to my particular construct. So the shape of this object here that I've highlighted, I've got to define that uh, type essentially. I've got to define a type for this object. For this object, right? So if I look at the auth API, here's my type. And what it is a type for the properties of an auth API L2 construct. Okay. Where am I using? So this is where am I using this type? I'm actually using it in the constructor. Here, you can see it being used here, right? It's the third argument. The third argument of any L2 construct. Generically, we name the argument the props argument. Its type then depends on the nature of that L2 construct. But because this is my custom L2 construct, I have to define what is the shape of the props object. And, I've decided to just keep it in the same file. I could have put it into I probably should really have put this into a types .d.ts file, but it's okay. It's okay where I have it here. And what is the makeup of this props object? That really depends on what kind of information I need to pass into it. In my case, The only thing I need to pass into it is the user pool ID and the user pool client ID. If there were other stuff, you just, add it into the this type definition. Okay, so in a sense, we don't have to step through the detail of this auth API construct because it doesn't have anything particularly new in it, right? As in, look, we're just creating a REST API. We are, uh, adding endpoints or resources to our API, adding another resource. Which one am I looking at? Sorry, I'm looking at the auth API. And as well, I'm also creating my various lambdas. Now, again, just for convenience, um, creating all the lambdas and connecting those lambdas or integrating those lambdas to the endpoints of my auth API, because there's a lot of code repetition involved there. What I've just done for convenience is defined a local function I just called it auth, add auth root, yeah, and that takes care. And I'm calling that method multiple times here. I'm essentially calling it for every endpoint in my auth API, and I can tell you, that the endpoints are the sign up endpoint, the sign in endpoint, the confirmation sign up endpoint, the sign out endpoint, and I think there might be one other as well that I've kind of forgotten. Okay. So all I'm doing here is just calling that private function that I've defined down here. And what does the private function do? Surprise, surprise, it creates a lambda function. Nothing exciting there. And it also adds a method to the relevant resource, API resource or API endpoint. So there's nothing new there from a CDK point of view, just slightly structured it differently. The same is true of the app API L2 construct. It's doing the exact same thing almost, right? It's creating let's see, it's creating a REST API. It's creating two endpoints or resources, some lambdas, and connecting them all up together. So you can look at that yourselves later on. So I've deployed all of this, and if I go to Cognito, I go into Cognito, and I go to user pools. There I have my user pool. And if I go into that user pool and select users, there's no users yet, so nobody has registered. If I go over to API Gateway, I have two web APIs, the auth one and the app one. And if I go into my Lambda section, I've got a bunch of Lambdas there. And the Lambdas are, as we said a number of times, all of the auth Lambdas and the two Lambdas for my app API, the protected and the public one, and the authorizer Lambda as well. So they're all there now. So let's step through some of the lambdas. So the first one is the Lambda that handles a sign up or registration request. Let's just do a registration first. So over we go again to Postman. It's asking me here. I don't want to do anything with upgrading. Oh, can I just dismiss that? So I've got a Postman collection here for convenience, and I've got some variables set up for myself. And the two variables contain the URL of the Auth API and the URL of the App API. So I've set those up already. We'll come on to the third variable in a second. So for a sign up is essentially going to be a post request to the Auth API slash auth slash sign up. That's the way I just defined my sign up endpoint for my Auth API, my Auth Web API. Okay. So if we did look through the Auth API L2 construct, hopefully we should find an endpoint that has that path name, and it should have a post method associated with it. And the payload for the post, okay, we would have to decide that, but this is what my payload is going to be: a user's username, a user's password, and a user's email. And we do need an email, as we'll see in a second. So I'm sending the email to my Gmail account. So if I trigger that, so the request is going to the Auth API. The Auth API is forwarding it on to the sign up Lambda. We haven't looked at the sign up Lambda yet. The sign up Lambda extracts this payload from the event object, and it essentially talks to the Cognito service, asking it to essentially create a new user in my user pool where the user's uh, details are these details here. Now, because of the way I configured my user pool, the user has to has to confirm their registration or confirm their sign up. So I did see, it looks like I did get a 200 response back from the sign up Lambda. And if we now just look in the Cognito user pool, we now have a user whose username is user A, email address is that. But if we scroll over here, you can see that the user is unconfirmed, to use Cognito's terms, meaning they haven't confirmed their registration. And the way confirmation works, the kind of default uh, authentication flow is that Cognito will send an email to this email address, to my email address, with a code, and I have to just verify that code. You know, that's what we typically do in a lot of cases. So if I now just open up my Gmail, so I can tell you this is the email that was sent to me by Cognito. And here is is the code. I tested it earlier on. So here's the code. This is the most recent email that I got. So I need to take that code and I now need to go through the confirmation process, which is sending a post request to a different endpoint. And it's this endpoint, again, of the Auth API. It's a post request. This is the payload, and I need to put in the code. And I do have to tell it who's the user. Send that. Or, and it looks like I got a successful response back from the confirmation Lambda. So that there was a second Lambda now used in this case to deal with this. And if I flick back to Cognito, and if I do a refresh, we can see that the status of the user has changed now to confirmed. So, something has happened anyway. Okay. So what's been happening now, if I go back to here, I have sent, first of all, I sent a request to the sign up endpoint of this API that routed the request to my sign up Lambda, and the sign up Lambda talked to Cognito to essentially create the new user. Then I sent a second request to a different endpoint in this API, the confirmation endpoint. The API routed that request to a different Lambda, and that Lambda again talked to Cognito, asking it to change the user status from unconfirmed to confirmed, provided, of course, that they provided the correct verification code, which Cognito would take care of because Cognito generated the verification code. So there's two Lambdas there. So let's look at the sign up Lambda first. And here's our kind of excerpts from it. Now, what I mentioned there a while back was that what's nice about the it's not really CDK, it's the AWS SDK, the software development kit. Every service has an SDK which allows us to programmatically communicate with that service. We've seen that at DynamoDB, right? And you might remember in DynamoDB, the kind of programming model was all about, first of all, you get an instance, or you create an instance of a client for that service. It would have been a DynamoDB client in that case. And then we invoke the send method of that client and we pass it a command object as a parameter, right? So in the case of DynamoDB, there was an update command object if we wanted to update an item in the table. There was a put command object if we wanted to add a new item to a table. Now, it's the same programming model with Cognito because the Cognito SDK is designed in a similar way to the DynamoDB SDK. And as I did say earlier on, it turns out that all of the other services SDKs follow that programming model as well. So that's kind of nice. There's no new kind of learning involved. So here we go, right? In the case of our Cognito service, we're creating an instance of the Cognito client. So this is the Cognito client that's available in the Cognito SDK. For most of the clients, the only thing that you have to tell us is what what region. Okay, that was the same with the DynamoDB, if you remember. So, right, I have now a reference to a client that will allow the rest of my Lambda to talk to Cognito. So here's my Lambda handler function. It's just an ordinary API gateway proxy handler type function, which is the exact same for the DynamoDB ones. I'm just extracting the different parts of the payload that were included in the post request to this endpoint. This is the sign up endpoint now, right? So I'm extracting just some data from the event body. And here we go. In the case of, if I sort of skip down to here, really, we do client.send, and we send it a command object. The command object in this case looks like it's a sign up command object, sensible name, right? So this command object again is provided by the Cognito SDK, and the parameters or the configuration of this sign up command object you can see here, right? And for nearly all of the different command objects associated with Cognito, you always have to specify, you always have to tell it what user pool are we trying to talk to and what client. Do I specify the user pool? No, it looks like I only need to specify the user pool client in this case. Because the user pool client actually has a reference to the user pool itself, so I don't need both of them. And so this is just the specifics for this sign-up command. Tell it the user pool client, what was the username included in the registration, what was the password included, what was the I think what this is doing is it's extracting just the email part of the post body as well. Yeah. The body was, remember, the body was for the sign up. This was my body or my payload. So the last part there is extracting. So there could be other key value pairs inside here, right? Depending on how much information you want to store about a user. But in terms of sign up, it looks like that we are using email. Email has an important role. Well, no, sorry, I'm sorry. I'll rephrase that. Apart from username and password, there can be other key value pairs here. And in the registration, in my case anyway, there is only one key value pair, email. And so that's really kind of what this is doing, is telling it what other parts of the payload should we extract and store as user profile data. Yeah, and so, the client.send now is effectively communicating with Cognito and asking it to create a new user in my user pool. And now I probably should have a try. Well, I do have a try catch block, but I should probably in here, I should check to see that the response is something sensible. I'm kind of taking the happy path and I'm just returning straight away. But we'll accept that weakness maybe in what I'm showing you here. So that's the sign up Lambda. Nothing terribly exciting, I don't think. It kind of flows fairly standard. For the confirmation of the sign up, I demonstrated it to you. Here's the Lambda that, sorry, that's not the Lambda. Here's the Lambda that deals with the confirmation sign up processing, and it has the same flow of control, right? Create a Cognito client. In this case, the command is, what is it? It's a confirmation sign up command. Surprise, surprise. And we send the command to the client and all of that stuff, right? In this case, the payload has just the username and the verification code that was returned. I'm extracting that from the body of the request that was sent. And we saw that, didn't we? I go back here. We saw that in the confirmation. here was the body. So I'm just extracting these from the body of the request. Yeah. For us a login then, uh, let's just do a login. Login is also happens to be a post request. It's also to the auth API. Oh yeah, it's to the auth API, but this is the actual path that we're sending the post request to. This is the payload. Click send. Now in this case, um, what I've decided is that, well, sorry, in the case of a login, Cognito is going to generate a JWT token for me. And what I've decided in my implementation is that I'm returning the token in the response body, which is okay, but maybe that's not the best idea. But I'm also returning it as a cookie, which would probably be a more common way of doing it, or a slightly safer way of doing it. So if I click send anyway, again, it's a different Lambda now that's dealing with this request essentially to the auth API. And I've decided to actually show you the JWT token in the response body, which is what you're kind of seeing here. But I'm also including it as a cookie in the response. And we can access cookies in Postman by clicking on this cookies link here underneath the send. So if I do that, and in general, a response could include many cookies. Uh, and in the case of Postman, we would see them all listed down here. A cookie, as you know, is just a key value pair. The key can be anything, the value can be anything. In my case, I've decided I'm going to have a cookie whose key is called token, completely arbitrary name. The value of that cookie, in my case, is the JWT token, which is what you're seeing here. So I need to copy that now because I'm going to use that in Postman. So if I copy that and go into Postman, and again, I'm going to put it into a Postman. All right, I'm already in Postman. Put it into a Postman variable. If I can exit out of this. And now just bear with me. There are literally things in my way now, Zoom things in my way that aren't allowing me to click on them. Let's see if I can do it this way. Okay, got there. So I've just got another Postman variable here, which I've called JWT token. And the value is what I copied there from. So the value is the full cookie, right? So it's the full cookie, and a cookie is a key value pair. As I said, I decided the key, in my case, I've just arbitrarily given it the name token, and the value then is the actual JWT token. So I've got a variable called that which has the full cookie that I need. Uh, to sign in, then I need to uh, I need to send that JWT token, and again, arbitrarily, I've decided to send it as a cookie. I could have sent it as a special request header. They would probably be the main options. You certainly wouldn't send it as the body of a request. So I've decided to send it as a cookie, as a request cookie. And oh, sorry, no, sorry, what am I saying? Sorry, I beg your pardon. Okay, I've just logged in and I've received a JWT token, which I can now subsequently use when I want to make requests to the app API. Sorry, I confused you there now for a second. So I've just signed in or logged in, and the response that I got back included a JWT token. That token was contained within a response cookie, and I've now just stored that cookie locally for myself. Okay, so the next thing, if I go back to here, I now, up to now, we've been dealing with this API. Now I want to deal with this API, the app API. And I want to send request, which is trying to trigger, let's say, one of the protected lambdas over here. I only have one protected lambda, but I need to include the JWT token so that my authorizer can say, yeah, you can access the protected lambda, or no, you can't. And I've talked about this already. And again, I've arbitrarily decided that the JWT token will be sent as a request cookie. Alternatively, I could have sent it as a request header, but I've just decided arbitrarily to use the cookie mechanism. So let's just do it first. So here's the protected endpoint. Its URL. Notice now that we're using the app API now, not the auth API. And I've just decided that the path is /protected just for convenience. It's a GET request in this case for no particular reason, but I have to send a cookie. So I need to set up my cookie settings here. And you can see I have a cookie. Well, in fact, a cookie is actually a header. It is actually, sorry, no, a cookie is actually a request header. So anyway, here's my setting for my cookie request header, and I've just assigned it to the variable that I defined there a while ago, my JWT token variable. As we know, the cookie request header can, as its value, it can include many cookies, and a cookie is a key value pair. So if I had other cookies that I wanted to include in my request, then, I would just tag them on to this value here. And the cookies themselves, they're colon separated. So I'd have a colon, some other key, its value, another colon to separate the next cookie. And the meanings of these cookies, just depends on the application. In my case, I definitely have one cookie where if the cookie's name is called token, then the value is a JWT token. And that's important because my Lambda that's going to be handling this request, well, sorry, it's not the handler, sorry, it's the authorizer. The authorizer needs to know, where do I find the JWT token in the request? Now, I haven't shown you the configuration of the authorizer yet, but we'll do that in a moment. So in general, there could be many key value pairs to make up your request cookies, but just not in my case. Let's just send that request. Now, again, I'm pausing again because I need to move some Zoom stuff that's in my way. So here's the response that I got back. Now, that response was generated. What does the response say? You received a protected message. Okay, so that was, I now go into VS Code, go into the actual Lambda itself, the protected Lambda, which is this guy. And, there's anything interesting in it, just has a console log. And if we just we'll ignore this stuff for the moment. And here's the returned response. And there's the actual message that I got. So that seemed to have worked. It did seem to, it got through the authorizer, if you like. And the authorizer allowed the request to be forwarded on to my protected Lambda. Now, we're missing some bits though. So let's go back to our slides. This is the actual sign-in Lambda. Again, it follows the same flow as in get an instance of your Cognito client. The command in this case is this command. Sorry, now this is the Lambda that's handling a sign-in. So I pass in a username and a password, and it needs to talk to Cognito. It needs to talk to Cognito. Cognito returns generates a JWT token and returns it back to the client, which is Postman in my case. And you can see here where I'm using the set cookie. The effect of that is to create my response cookie, which I then accessed in Postman. And I'm also just including the actual token in the body of the response here, right? Which is fine just for demonstration purposes, but you probably wouldn't. And if I go right back to here, right, where I'm actually talking to Cognito, so I do my, where do I do it? Oh yeah, client.send, and I send my command. And the response that I get back from this, in this case, is an object, but there's one particular part of the object that I'm extracting here. And it's in here is where my JWT token is, as you can see from the flow of control that's going on here. That's how I actually extract the JWT token from the response that I get back from Cognito. That's okay. That's okay. We've looked at that. All I'm showing you here is that, like, what is a token? What is a JWT token? Really, all it is an object structure that contains some information, and it has been encoded, right? So if you wanted to see what is the actual decoded form of a JWT token, well, one way you can do it is you can go to this website here, and if you just paste in your JWT token, what it will show you on the right is the decoded form of that token. And that's exactly what I've done here, right? This is a token that was generated by my Cognito uh, service for my particular user pool. And if you look at the data structure here, and I've kind of highlighted within the data structure, there's other useful information, but in particular, what you can find inside here is the username of the user for whom this JWT token was generated. Now, I registered a user whose username was user A, and you can see, we can find user A, we can find the user's username within this decoded version of a JWT token. Now, here I'm just doing it on a website, but you can do this decoding programmatically as well. Uh, and we'll come back to that in a moment. But for now, just be aware that there is some useful information within the JWT token, or potentially useful information. In my slides, I'm now moving on to this API, which I've already kind of demonstrated to you. Oh yeah. Now, what I'm showing you here now is some code from the stack that creates all of this infrastructure here. The API gateway, that's nothing interesting. We know how to create an API gateway. These lambdas here are standard lambdas, but the infrastructure code that creates your authorizer, that's the only thing that's new, because, okay, this is just an ordinary lambda, but you do have to somehow indicate that this lambda has a specific role within this overall application, and its role is to act as the authorizer of a request that includes a JWT token. And so that's what I'm showing you here. I'm just showing you how do I actually declare this lambda as being the lambda that plays the role of an authorizer. Okay. Okay, so this is just creating the actual app API. This is just adding the endpoints. I've collapsed it, but let's supposing this is the lambda of the protected endpoint. This is the lambda of the public endpoint. And this third lambda is the lambda that's going to play the role of my authorizer. But for now, so far in this code, it's just an ordinary lambda. Here's where we make the lambda play the role of the authorizer. So there's yet another built-in L2 construct called request authorizer. Yeah, it's as simple as that, really. And in the configuration of it, I'm referring to my actual lambda function. That's what this reference is here. And there's some other configuration settings as well. Well, of particular importance is this one. This is indicating where in a request will the token be stored. And I decided that I would store my tokens, or I would include my JWT token as a cookie in a request. So that's what this piece of configuration of the request authorizer, that's what it's kind of telling the lambda in a way. The rest of it is okay. We're just telling it don't do any caching of tokens. And here's how so all I'm doing here is actually declaring my request authorizer. I now need to indicate, well, which particular endpoints in my app API will require authentication. And that's what I'm doing here. It's part of the add method association of an endpoint. We've seen the kind of Lambda integration before. Well, here's the new part of the configuration of my Lambda integration, where I'm pointing it at an authorizer. This is essentially pointing at this guy up here. So from a infrastructure point of view, you need to first of all have a Lambda. You then need to have a request authorizer, and then you need to specify which particular endpoints will use this authorizer. And we can see that the other one, the public one, it's not using it at all. I've shown you triggering that, and that's okay. Now, we could look at the authorizer code, I'm providing you with the code, and it works, and you can certainly, and probably should, just scan over it yourself. What I'm actually doing here is just describing what the authorizer does, right, rather than stepping through the code. So just quickly to go down through it, the first thing it has to do really is it has to essentially extract the JWT token from the request. Now, the way I've done it is I first of all find the request cookie header, but that's just a big long string with a set of key value pairs, but it is just a big long string where colon is used to separate one cookie from another cookie, and a cookie is a key equals a value. So we need to kind of parse that whole big long string, and I've parsed it and put it into a map data structure. And the keys in my map will be my cookie keys, and the values will be the cookie values. And I then look inside that map for a key called token, because that's how I actually store it. And the value associated with that key is my actual JWT token. So, that's just a bit of data processing, the string splitting and stuff that's going on early on in the authorizer. So eventually, let's say I find a key called token in what I'm calling my cookie map. Of course, if there is no key called token, then I know a JWT token wasn't included. And so my authorizer should return. This is where where I was talking earlier on about my authorizer is going to dynamically generate an IAM policy. So my authorizer Lambda is going to generate an IAM policy that denies access to the backend, and it returns that policy, if you like, to the API gateway, and the API gateway uses that policy to determine whether it should forward the request on or not. If assuming it has found this JWT token within the cookies request, it now needs to verify it, and there's just some code. It's actually using a kind of a remote website or a remote web API that's specifically set up by AWS to do that. But you can see that code and you don't need to make changes. It just works, right? So the end of the verification process is either going to be yes, it's a valid token, or it isn't. And it's the same thing. If it's a successful verification, then my authorizer is going to, again, generate a dynamic IAM policy that will allow API Gateway to pass it on, else it generates a policy that denies it. So by all means, kind of correlate this description with the actual code, but you don't need to dig deep into understanding every line in the code. And that's kind of it, really. Certain stop. Let me just see. Yeah, here's the actual authorizer. But because there is quite a lot of There's quite a lot of logic in the authorizer. I have separated it out into local utility functions. You can see there's a utilities TypeScript file here, and the utility has functions whose name kind of makes sense in the context of this overall authorization process. Like there's a function called, let's see, uh, that's just a type, parse cookies. So that's a function that takes this big long cookie request string and kind of parses it up. There is a function called verify token, function called create policy. And like I said, you can scan over them if you'd like yourselves, just to make sure you know what's going on there. The last thing I will mention is let's go back to here, right? So this authorizer lambda, it does all of the stuff we were just talking about. Uh, but um, there's nothing stopping you having some code in these lambdas over here. Maybe the lambdas over here, they want to access the token as well, the JWT token. Uh, if I just rewind, so the request comes in, and in the request, in the cookies header, that's where the JWT token is, as we know, right? But that cookies header will actually be included in the request that's forwarded on to your backend lambdas. So that means these lambdas over here, if they wish, they can actually access that JWT token, and they can decode it. By decoding, we mean they can, take this and produce this. And this is just a JSON structure, and they can index into this JSON structure if they want to pick out some particular piece of information. Yeah. So these lambdas, if they want to, they can do that. Now, I've actually done that in the protected lambda just to prove it to you. So that's what I'm doing here at the beginning of my protected lambda. I'm essentially trying to get at the actual JWT token. I am the way I decode it is by using the verification process. I should probably say that actually. Because what the verification utility function does is it returns the decoded form of the token. That's kind of a way of saying, yeah, it's a valid token. If it can't decode it, then it's an invalid one. And if you look here, I am doing a console log of the decoded, although I'm calling it the verified here, console log of the decoded or verified JWT token. And this is inside in the protected lambda now. So if I jump over to CloudWatch logs, and if I go to the log groups, and if I find the log group for the protected one, let's see, which one is it? That's it there, actually. And here's the log stream. Now, my protected Lambda has two console logs, one at the very beginning, which just console logs the full event, which we always do, which is always a good idea. And just as we're on that, actually, if we expand that, so what we're looking at here now is the event object. And as we know from last week, when the event object, when the source of the event object is API gateway, we can see all of the HTTP headers that were included in the request that came from the client, Postman in my case. And lo and behold, there is a header called cookie. And here's the JWT token. Okay, so that header is there because in my Postman, uh, you know, I wanted to include this header as well as some other headers as well. Okay, so that's just by the way. Now it's the second console log though that I'm interested in, which is this is the part of the stream that relates to the second console log, where I'm essentially console logging the decoded form of the token. And for example, this property here is telling me that this token was generated for the user whose username is user A. And there might be some other parts of this token that might contain useful information to the backend Lambda that contains our application functionality. Right. That's that. So that's all I'm going to do. Sorry, that's all I'm going to do in relation to Cognito. And in this week's lab, you will be developing all of the code that I've stepped through some of it there, and you'll be exercising that code using Postman in the same way that I did it uh, here for you live. Which means all I want to talk to you, all that remains really is for me to go back to here and bring up the assignment spec. And this is kind of where I stop talking, and hopefully you may have some questions anyway for me. I'm just going to open the floor to E at this stage and ask E, are there any aspects of this spec that you're unclear about? I'd need people to, if you do have any questions, I prefer if you actually just spoke them out rather than type something into the chat now. No, okay. In that case, I'm just going to do a quick overview and then we're going to leave it at that. So it's about developing a web API, surprise, surprise. And I've decided that the web API is for managing movie reviews. Okay, specify the hand update. There isn't going to be much, there isn't going to really be any flexibility in that hand update, unfortunately. So we're 30%, just some details on what you actually submit. You won't be submitting, uh, well, indirectly, you'll be submitting your GitHub repo, but really what you upload to Moodle is just a simple text file, .txt file that contains the URL of your GitHub repo and also the URL of a short YouTube video where you demonstrate the application. The video will be roughly about 10 minutes or so, whatever you need really fully demonstrate the code. And I can give you more details on what you should or should not include in the demo later on. I won't talk about it today. It's very, 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 very important that you maintain a Git history of the development of this uh, assignment. Okay, if there's no Git history, then I'm going to assume the worst. So you need to be very, very careful about that. And that's all explained here. And you don't have any questions about it, so I'm assuming you understand it fully. The details then of the actual, so again, we have this kind of app API, auth API, because authentication is going to be part of the assignment, but you can completely reuse all of the code that you will develop in this week's Cognito Lab. I'm allowing you to completely reuse that code. All you'll be doing really is stitching in a different app API from the app API that's in this week's lab. And the app API, I'm giving you the details of it here. Okay, so it looks like there's 1, 2, 3, 4 endpoints, and you have the details of the endpoints there. And you haven't asked me any questions about those, so I'm assuming everybody is clear on those. Authentication is we're saying that only the post and the put endpoints. Only the post and the put endpoints require authentication, meaning your JWT token has to be included in the cookie request header for these guys. Doesn't need to be included in the other ones. From an authorization point of view, from an authorization point of view, post and put need authorization. Sorry, I was talking about the post and put up here. The post and put need authorization, which means they need to have a valid JWT token included in the actual requests. Additionally, I'm saying that the user that originally created a movie review, only that user can update it. So the push request, not only does it need to have a valid JWT token, but the user has to be the same user that sent the post request for that review. So you need to work out how do I kind of achieve that. The database, the data model for this application just consists of 3 entities: a movie, a reviewer, and a review with the properties that I'm showing you here. So movies have an ID, etc. Reviewers have an ID, which I actually changed this morning. I was cheated a little bit. I had email, but let's say that the reviewer's ID is their username, which is essentially the username that they used when they registered. And just going back to Postman. So we're assuming that kind of reviewers will register, or they need to register first, or at some stage. And they provide a username and this other stuff as well. So the reviewer's username is what I'm calling their reviewer ID in the spec. And because of the limitation on, did we come across that already? I wonder, there's a limitation in terms of how many email addresses you can get Cognito to send emails to. I'm not sure if I covered that already with Witchy. If I haven't, then it's definitely covered in this week's lab. I talk about verified identities. Your AWS accounts are what are called sandboxed accounts. And in a sandboxed AWS account, you're only allowed to programmatically send emails from your account to what are called verified email addresses where you actually have to uh, set up the verified email addresses yourself. And I explain how you do that in this week's lab if I haven't done it already in a previous lab. I just can't remember whether it was something that arose in a previous lab or not. It probably didn't actually. So as long as you've got at least, let's say, two email accounts that you own, then you can set those up as what are called verified identities in your AWS account. This is something that you do kind of manually now, not programmatically. So for example, in my AWS account, because I own this email address, my Gmail address, then I set it up as a verified identity in my AWS account, which allowed me to use it here, right? And so let's say you will have, let's assume that you have at least anyway two email accounts that you own, then that kind of means you can set up two reviewers, and that's as much as you would need really. But from the API's point of view, we kind of use username. We're going to use usernames as a reviewer's ID, and that's what we use in the DynamoDB database as well. And finally, a review then, because a review is kind of a relationship between reviewer and movie. Then a review has a movie ID, a reviewer ID, in other words, their username, and the actual text, the date of the review, and the actual text of the review itself. Okay, so that's the data model. Now, here I'm saying in DynamoDB, I'm asking you to follow what's called the single table uh, design or pattern. Like in the labs that we've done so far, we've kind of modeled the database as if it was a relational database, which of course it isn't. DynamoDB isn't. So, we had a movies table and we had a movie cast table, and we could have had an actor table as well if we wanted to. So we kind of broke up our DynamoDB database into tables, which is the way you would do it in the relational world. But in a non-relational world, you don't necessarily follow that approach. And I'm explaining and I'm giving you the exact design here rather than asking you to come up with design, because we haven't covered this single table approach towards designing DynamoDB databases. So the overall kind of idea is that you actually put all of your data into one table. Now, in our case, all of our data consists of movie data, reviewer data, and reviews data, three different entity types. We're going to put all of that into one table rather than having three tables. And the way you distinguish then one item from another item is you use the primary key, which is a combination of partition key and sort key. You use those to actually distinguish or to kind of indicate what type of entity is an item actually storing. Is it storing a movie? Is it storing a reviewer? Or is it storing a review? And I explain how to use the partition key and sort key to distinguish one entity type from another. So that's all explained here, and I'm not going to talk my way through it because you haven't asked me any questions, so I'm assuming you're clear about that. And I'm giving you some sample items that might appear in the table to further clarify what I'm describing up here. So we can take this one, for example, because this is the partition key, this is the sort key. Because the partition key begins with M hash and the sort key begins with M hash, then that's telling us this item in my table is actually representing a movie. For this one, because the partition key begins with, sorry, did I do the right one? Oh yeah, because the partition key begins with M hash, and the sort key begins with R hash, that's telling us that this item in my single table is actually representing a review, and the third one is representing a reviewer. Both keys begin with R hash. So this prefixing of the keys, that's the technique that you use in order to achieve this single table design. And the last thing I do then is give you the grading spectrum. So if you're just looking for 4255, just get all the gets, the two gets working, get the post working. You don't actually have to have any authentication. If you're looking for something higher, this is what you've got to achieve. If you're looking for the 65 to 80, then there is there may be, and there is actually an opportunity to define a local secondary index in your DynamoD database that will be useful to your uh, backend implementation. So you've got to see if you can identify what would be useful LSI, local secondary index, for our table based on the endpoints that we have defined for our app API. Lambda layers is something we did not talk about, so you're going to have to look up that. But the essential idea behind Lambda layers is, like when we run CDK deploy, as well as generating the CloudFormation template, what the CDK framework actually does as well is it takes each of the Lambda functions and it packages those. And a Lambda function package includes the JavaScript equivalent of the TypeScript code in our case. Okay, so it compiles the TypeScript code to generate the JavaScript, but it also includes the contents of your node modules folder. And it includes the contents of the node modules folder in every Lambda package, even though it's the same node modules folder for every Lambda. And it uploads the Lambda packages, as I'm calling them. There probably is technically a better name for them. It uploads those. They're actually stored, I think they're actually stored in an S3 bucket, right? And so, as well as the CloudFormation template, uploading that to the CloudFormation serverless, it also uploads all of your individual Lambda functions. But each of these Lambda functions now is quite chunky because it has all of the contents of your node modules folder. A better way of doing it is to put all the contents of the node modules folder into one unit, and then each of the Lambda packages needs to only contain the actual Lambda JavaScript code. But up in the Lambda service, create a connection between a Lambda package and this other package that just contains the node modules folders. That's what we call Lambda layers. So your Lambda is now a layer. It has two layers in our case. It has the JavaScript package layer, and it has the layer that includes the node modules the node modules. So you have to look up how do I actually achieve that? And it's stuff that will go into your stack file. You kind of describe that in the stack file. There may be some slight changes that, as in probably an import statement change in your Lambda TypeScript code. So you have to Google around that a little bit. The last thing is API gateway validation. Oh, we're out of time. Okay. Which I do just briefly want to talk about this RIT. And if I go back to my slides, so if I go right back to the beginning, okay, these are the slides that we worked our way through when we were talking about the API gateway. Are they? Yeah. And if you scan down through them or flick through them, at the end of this set of slides, there are one, two, three slides that talk about API gateway validation. So what API gateway validation is about first is let's see if I just bring up okay, let's take it from here, right? So a client, let's say, sends a post request, or any type of request, sorry, any type of request to API gateway, and API gateway routes it to the relevant Lambda. Now, you can do a certain amount of validation of that request, or you can configure API gateway to do a certain amount of validation of that request. And based on that validation, it either passes the validation, in which case it passes the request on to the actual backend Lambda function, or the validation fails. And if it fails, API gateway will actually send an error response back to the client, and it doesn't bother forwarding the request onto the Lambda. And clearly, from a kind of performance point of view, that's better, because if the API gateway did not have this validation feature, then it's going to be sending on invalid requests potentially to your backend. Now, your backend should still do some validation. And we were doing the validation inside here. You might remember we were validating the body of the request, if there was a body, using that AJV library. Yeah. So we're kind of now essentially, in some cases anyway, we are delegating the validation now to API gateway. And so there's less work potentially required by the actual Lambda function. And also we're getting that kind of quicker response back from our overall request if the actual request is invalid in some way. The types of validation that API Gateway can do is it can do validation of the query string. So if there are query string keys that must be included in the request, and those keys are not included, then API Gateway can catch those and it will send an error response back. It only works though for query string keys that are mandatory. It doesn't work for query string keys that are optional. So, it is quite limited, the validation, but there you go. Also, if the path of the actual request contains or includes a path variable, like in our case, maybe /movies, /movie ID, /reviews, where a movie ID is a path variable, API Gateway can check to make sure that there is actually a path variable there. It obviously cannot do anything about is it a valid movie ID or not. It's not that sophisticated, but it can check to see that there is essentially something between the /movies and the /review part of the actual path string, if you like. So it can check for the presence of path variables. The third thing it can do is it can, if a request includes a payload, as in a post request or a put request, then it can validate the structure from a schema point of view of that payload. So there are three types of validation: query string validation, path variable validation, and what it calls, I think, model or body validation. And that's what I'm talking about here. Okay. Uh, Here I'm saying from a kind of CDK point of view, we have to create some more L2 constructs, right? And link those L2 constructs or hook them into our web API. Uh, there are two constructs that are relevant here. One is called the validator construct. The other is called the model construct. So you have to find out really yourselves, how do I create these and how do I configure them for my particular use case? So there are these two constructs anyway, validator and movie. And these constructs will result in CloudFormation resources. There's almost a one-to-one. So in fact, they're more like L1 constructs than L2 constructs. But it doesn't really matter whether they're L1 or L2. They're constructs anyway. And the last thing you need to do then is to kind of link them all together. Now, by link them all together, I'm describing how the linking works here in this picture. So what I'm showing you here is, let's suppose we've got a web API, and for simplicity's sake, it has two endpoints. And the endpoints are linked to lambdas, and that's fine. And the lambdas talk to a database, although we don't really care about what's going on down here. We've got these two endpoints. And let's supposing this endpoint, we want API Gateway to do some validation before it decides to route the client request onto this endpoint. So we would have to, we don't need to go into the detail now of, is it a query string validator or is it a path validator? What I'm trying to get across here is there is a validator resource that we have created, and there's also a model resource. The model resource is the one that kind of describes the structure of a payload that might be included in a request. And we want API Gateway to validate the schema of the payload against this model that we've defined for ourselves. So we have a model and we also have a validator. And you kind of, when you create the validator, you connect the validator to the API gateway. It kind of works in that direction rather than this direction, just by the way, right? Similarly, your model resource will have a reference to the API gateway that it is being used by. Because, in general, an application might have many APIs. And so just because you create a model and a validator and you've got many web APIs, you've got to tell probably CloudFormation, I suppose, really, which API, web API, is a model being used by, and similarly for the validator. And if the validator is, remember I said there were three types of validators: query string, path, and model validator. If the validator, in fact, it can be both. It can be a combination of those. But if the validator, oh no, sorry, no, forget that point, sorry. Also, in terms of hooking all of these things or linking them all together, you also have to specify in the endpoint configuration, you have to point it at the validator that's being used by API Gateway to do validation for that endpoint. And if the validation that's done for an endpoint includes body or model validation, you've got to, in the configuration of the endpoint, you've got to point it at the particular model that's being used by API Gateway to perform the validation. So there's a lot of just connecting all of these things together. And the connecting of them all together is again specified in your stack file. So your stack file instantiates these guys, these kind of L2, let's call them L2 constructs, but it also has to create these connections within the stack file. And once you've done all of that, then API Gateway does the rest. Then it knows when to, when to perform a validation or when to use a particular model to check to see is the payload of the request, does it match the model, the schema? It knows when to do that because you've told it, look, it has to use this model for this endpoint. And let's suppose this is a post endpoint, right? So there's a bit of research that you've got to do, I guess, in order to get all of that working. And that's why I've put that, going back to our spec, that's why I've put it at the top end kind of the grading spectrum. Some notes down here. I think probably the most important one is number, which one is it? Oh yeah, well, they're all important, but number 3, pay attention to. What I'm essentially saying in number 3 is, your client, which will be Postman in our case, it might be a React app though in real world. Your client doesn't really need to know about the detail of your database design. So all of these kind of prefixes that we have in our partition key and sort key, the client shouldn't need to know anything about that. All the client needs to know is what are the IDs of the entities, as in a movie ID, a reviewer ID. And that's what it should be using. So if we go back up to here, let's say here, like where we have get/movie/movie ID/reviews. Well, a movie ID will be something like 1234. It won't be M hash 1234. If it was the latter, then we're essentially kind of exposing the internal design of our database in our API, and that's not a good from a pure design point of view. And similarly for the other entity IDs. Right. I am finished for today. And it doesn't look like you have any questions. I'll give you another opportunity just in case something has come to mind. No? Okay. If something does, I suppose it's not really until you got stuck into this assignment that you realize I'm not actually clear about something. Then you can contact me over Slack and I'll try and clarify whatever misunderstanding you might have. Okay, that's actually it from me, not just for today, but probably for the rest of the module. Frank is going to take over from next week, and he's going to be focusing on front end. I don't know if I come in again at the very end. Previous years, I've come back again at the very last week to cover another service, really called CloudFront, but that may not happen this year. It just depends on what kind of progress Frank makes with his stuff. So that's it. I'll turn up as usual on Thursday. If people want to meet me face to face, and maybe you may then have 1 or 2 questions about the assignment spec. But in the meantime, anyway, you certainly have a lab that you need to work through. And as I've already said, the lab that you will complete this week, you can reuse all of that code in the assignment to to satisfy the authentication part of the assignment spec. Right, I'll leave it at that. Thanks. Bye-bye.